Before there was light, there was darkness. Before there was time, there was eternity. Before there was everything, there was nothing. And from that nothingness, a singular idea erupted. A solitary breath expanded, giving birth to all that we know, all that we see, and even all that we can never see. We have spent our entire history looking to the past, striving to understand the Great Big Bang. But there's an even bigger, deeper, and far more terrifying question. A question that haunts the minds of every philosopher, every scientist, every dreamer, gazing up at the night sky. Welcome back to ASTROM 225, the channel dedicated to exploring the greatest mysteries of the universe. I'm your narrator, and today, we won't be journeying to the beginning. We'll be journeying to the very end. Today, we confront the question, how will the universe end? Look around us, not just the room you're sitting in, but far, far beyond. Our universe right now is in the stelliferous era, the age of stars. It's a place brimming with energy, light, and creation. Every second, approximately 4,000 new stars are born in the observable universe. Each star is a colossal nuclear furnace, a fiery heart transforming hydrogen into helium, and in the death throes of massive stars, they forge heavier elements. The gold in your ring, the calcium in your bones, the iron in your blood, all of them are forged in the dying heart of a star. We, creatures made of stardust, are living in the golden noontide of the universe. A grand symphony of matter and energy is being performed, but every symphony has its final note. Every flame, no matter how grand, will eventually flicker and die. A fundamental law of physics, cruel and inescapable, is silently at work, like a predetermined sentence. It's called entropy. Entropy, simply put, is the universe's tendency for everything to move from order to disorder, from concentrated energy to dispersed energy. Every star is burning its fuel. Every galaxy is drifting further apart due to the universe's expansion. The universe is consuming its own energy. It's aging. Twilight is approaching. Now, let's fast forward time. Not a few years, not a few million years. Let's leap 100 trillion years into the future. That's 7,000 times longer than the current age of the universe. Welcome to the degenerate era. The night sky is now an almost absolute black velvet curtain. Giant blue stars, brilliant yellow suns like our own, have long since died. Stellar nurseries have depleted their gas. No new stars are being born. Universe's final candles are burning, and they are red dwarf stars. They are the last survivors, burning hydrogen slowly, frugally, for trillions of years. But even their modest lives must end. And then, the very last star dies. Light, as we know it, has officially been extinguished from the universe. Silence of darkness envelops everything. Universe enters an eternal night, but the universe isn't empty. It's just dark. Now, the stage belongs to the ghosts of stars. White dwarfs, planet-sized diamonds that are the cooled cores of dead stars, slowly fading into cold black dwarfs over millions of trillions of years. Neutron stars, matter compressed to the point where a single teaspoon weighs as much as the Himalayas, still spin furiously in the darkness. And the universe's new rulers? Black holes. They are monsters of gravity, space-time prisons from which nothing, not even light, can escape. In this era, life as we know it is impossible. All planets have either frozen solid or been torn apart. Energy is too scarce. Galaxies are no longer islands of light, but colossal stellar graveyards, drifting in an ever-expanding, ever-colder, and emptier space. If you thought 100 trillion years was a long time, you haven't seen anything yet. Let's leap even further, to a timescale that the human mind can barely comprehend. A 1 followed by 40 zeros? A Google years. Yes. Welcome to the black hole era. At this point in time, a strange process, predicted by particle physics theories but never observed, begins to occur on a grand scale. Proton decay. Protons, the subatomic particles that make up the nucleus of every atom, the fundamental building blocks of matter, are thought to be incredibly stable, but not eternal. Over unimaginable spans of time, every proton in the universe will decay. What does this mean? It means all matter, as we know it, will cease to exist. Cold black dwarfs will dissipate into thin air. Neutron stars will decay. Every last vestige of stars, planets, metacries, all will vanish, leaving behind only radiation and fundamental subatomic particles. A ghostly universe devoid of matter, almost all of it. Only the last kings remain, the rulers of the void, black holes. They are the only structures capable of resisting the decay of matter with their terrifying gravitational pull. For a ridiculously long time, the universe will be nothing but an empty space punctuated by these black holes, millions of light years apart. But even these immortal kings are not eternal. Thanks to a quantum effect predicted by Stephen Hawking, black holes also evaporate. They emit an incredibly faint stream of radiation known as Hawking radiation. This process is unbelievably slow. A black hole with the mass of our sun would take 1,067 years to evaporate completely. A supermassive black hole at the center of a galaxy could take up to a Google year's 10,100. And then the very last black hole dies. It explodes in a final flash of light, a faint farewell to a universe where no one is left to witness it. This is the last sound, the last light in the history of space-time. After that, only silence remains. We have arrived, the very end of time. The universe is now an unimaginably dilute ocean of low-energy particles, chilled almost to absolute zero. This is the most widely accepted scenario for the universe's end. The Big Chill, also known as the Big Freeze. Entropy has triumphed. The universe has reached a state of maximum thermodynamic equilibrium. No more energy differentials exist to perform any work. No more life, no more thought, no more meaningful movement. Time itself becomes meaningless. For if nothing happens, does time still exist? This is an eternity of emptiness, an absolute silence that stretches on forever. A tragic, solitary, and quiescent end. But is that the only possibility? Physicists, with their boundless imagination, have outlined other scenarios. Scenario 2, the Big Crunch. What if dark energy, the force currently accelerating the universe's expansion, weakens or reverses? Gravity would reclaim control. The universe would cease expanding and begin a grand collapse. Everything would rush together, temperatures soaring to billions of degrees. Black holes merging, and eventually all of space-time would collapse into a single singularity, an inverse version of the Big Bang. A death by fire, not ice. And this leads to an even more spectacular idea, the Big Bounce. Perhaps our universe is part of an infinite cycle of expansion and contraction. The end of this universe is simply the beginning of the next. Each Big Bang is the result of a preceding Big Crunch, an eternal cosmic dance of creation and destruction. We are merely a single beat in that unending symphony. And there's one more possibility, perhaps the strangest of all. The multiverse theory suggests that our universe might be just one of countless others, each with its own physical laws. Perhaps, even in the Big Chill, a random quantum fluctuation in the infinite void could miraculously spark a new Big Bang, a new daughter universe. The death of our universe would then be just a local event in a much grander meta-universe. A seed for a new forest, sown in the soil of oblivion. The Big Chill, the Big Crunch, the Big Bounce, the multiverse. We don't know for certain which future awaits us. Perhaps we'll never know. These timescales far exceed the existence of humanity, of Earth, of the entire solar system. So why should we even care? Because confronting the end of all things offers us an invaluable perspective. It reminds us that this moment, this era, our very existence, is extraordinary, precious, and incredibly rare. In the long, drawn-out history, in the cold future of the cosmos, there's a brief window where there is light, warmth, and planets, where matter can become self-aware. We are children of the stars, born in the golden noontide of the universe. We are the universe's way of contemplating its own beauty. Our existence, though but a blink in the cosmic night, illuminates all that darkness with consciousness, with questions, with art, and with love. The end may be inevitable, but the journey is what truly matters, and our journey has only just begun. Thank you for joining ASTROM 2025 on this journey to the end of time. If you're awestruck by the universe's grandeur, do we forget to hit like and subscribe to the channel so you don't miss our next adventure into the biggest questions. Next time, we'll seek answers to another mystery. Are we truly alone in this universe?